maybe it's up, I can open it to the audience also, maybe can someone tell from their mind what is, IoT, industrial of things, Internet of Things, or industrial Internet of Things? I can give a pause if someone wants to give a try, and then I'll give a brief intro of what is IIoT. We all are using Internet of Things in our day-to-day life, so just give your ideas of what you know about Internet of Things, or what you think about industrial Internet of Things. It's okay. Yeah. So Internet of Things is basically connected devices through sensor or other hardware devices that transmits data from one environment to another environment for processing, to gain additional insights about the systems that transmits the data. The industrial Internet of Things is very large scale. For example, Internet of Things is just getting the data or using your devices from your home. Industrial Internet of Things is like, for example, take a big city and gathering insights data from each home, and then gaining insights from each of the metrics of the data that you receive. Basically, it's a network of smart connected devices that enhances productivity and innovation in industrial settings. It involves real-time data analytics, machine-to-machine communication, and the integration of operational technology with information technology. Unlike consumer-focused IoT, industrial Internet of Things targets industrial applications with more complex systems and higher security requirements. If you see the real difference between IIoT versus IoT, IIoT is very a small application or a consumer-facing application, but IIoT targets industrial settings, where it involves very large-scale machines, data, sensors, connected through the very hardwares and networks. Going to the next slide. We'll see about what's the evolution of industry 1 to 4. You might already know, this is just for the wider audience. You see, late 700 to early 800, the mechanization via water and steam power, which is the industry 1.0, started. And then the mass production and assembly lines using electricity transformed the way, of how the industry are operated at that time. And then mid 1900 and late 1900, automation through computers and electronics started, and it shaped how we see the data. It shaped how we connects everyone, through the internet. And when we move into industry 4.0, which is now, and from the late 1900 to now, there are so many changes. Basically, it started machine-to-machine connectivity, the rise of data analytics, because we started producing a lot of data and started consuming a lot of data, and that's when we started processing very big amount of data. So this helps move into the edge computing. When we started consuming large amount of data, we need a large processing power, but it also helps us move the process closer to the data where it sits. And then we have a next advancement in the network integration, which is, we have complex networks of connected devices, sensors, and cloud platforms. If you see, you might all heard about Tesla, with FSDs, which is, you can just enable it, it will drive the car for you, which is enabled through cloud platforms, sensors, networks, everything. And then very recently, we have AI, machine learning integration started place. And with recent advancements in machine learning and AI, the autonomous is going to grow more. Now, we'll I'll take a pause here and see if we have any questions. Okay, I'll take that as no. Let's step into the architecture of IIoT. Since IIoT is at a very big scale, security is one of the main layer for IIoT, because nobody wants to break into the systems and manipulate the data. So security is very primary layer for the industrial Internet of Things. And then we have the perception layer, which has sensors, actuators, and smart devices. We will see one by one in the upcoming slides. And then we have network layer, which connects the machine and the processing side, or it will help transmit the data from one end to another end. And then we have a data processing layer, which basically collects all the data, process it, and do analysis. And then we have application layer, where it might be two types of things here. One, you gather the data, you provide some dashboard to the end user so that they can perform some actions, or you can feed the data into another machine and make it do some actions. Moving on to the next. Okay, so perception layer. So sensors are the primary component of the perception layer. You see, we have variety of sensors, which basically collects the physical data, gathers metrics. You know, depends on what sensor you use. It collects that information and transmit to another. For monitoring and control purpose, you have temperature sensor, pressure sensor, motion sensor, and vibration sensor. And nowadays, we are all calling these sensor embedded devices as smart devices. We all started using smart devices in our home. Basically, those devices will have sensors embedded into the devices. And moving on to next, it's a perception layer. The actuators are essential, component of IIoT, translating control system commands into physical actions. If I little bit elaborate, they serve as the muscles of an IIoT setup, enabling the system to interact with and manipulate the physical environment. Basically, it gives the commands for physical actions. For example, if you see an electric motor, it's widely used for rotatory machinery, and pneumatic cylinders, and we have solenoid valves and hydraulic actuators for high force torque and for heavy duty tasks. These actuators will be kind of a physical action, but it will also have some commands attached to it. And then we have network layer, which plays a very critical part in the industrial IoT, or I would say the central portion of the IIoT. It's crucial for providing reliable and secure connectivity between devices. It uses protocols and networking technologies to enable data transmission, allowing for real-time monitoring and control in industrial environments. We have different network types and network standards and even networking technologies. I'll just maybe give an example about networking technologies. What are all the different types of networking technologies? For example, you might have heard about Ethernet, Wi-Fi, Zigbee, and message, MQTT, which is message queuing, telemetry transport. And you might see LoRaWAN, which is a long-range area or long-range wide area network, which is used for low-power wide area networking protocol, designed for IIoT, especially in the industrial settings. The key features of LoRaWAN is it requires very small amount of power for transmitting data over a very large network or between very large area. It supports large number of connected devices in a very single network. And then you see Modbus, which is also an industrial automation system, which helps us data exchange between industrial electronic devices. Some important features are like it's freely available, royalty free, simple, used for both serial communication and Ethernet based networks. I'll take a pause here again. If anyone has any questions, feel free to type in or feel free to ask me. Okay, next, the edge devices. Edge devices is basically sits closer to the network side, I would say, because we don't want to send very large portion of data onto the data side. Sometimes this is needed to reduce the data volume that gets transmitted from one end to another end. Uh, this is this will help in improve the performance and also take actions within a milliseconds or within a very
Sir, please unmute yourself.
Am I muted all the time?
No, sir. Just for 5 minutes.
Okay, sorry, not sure how it got muted. I was just looking at my screen and I didn't realize that the mic got muted. Okay, did I cover the edge devices, or let me know which screen or which page that I need to redo?
The edge device.
Edge devices?
Yes, yes. After that,
Okay, okay, okay. The data processing layer. Okay, so the data processing layer is one of the critical component in the industrial IoT, because you have sensors, actuators that collects data, transmits data to the data processing layer, where you not only process but you also store the data. Uh, the reason for storing the data, it's very massive amount of data. You need to store the data because for historical purpose you need to take actions based on what happened before, or you need to gain insights of what has happened so that you take actions accordingly. So there are several things in the data processing layer, where you first store the data in the cloud environment, and then you have process the data using a lot of big data processing technologies uh, in different cloud settings. And we have talked about edge computing, which shifts the data closer to the processing layer. And then we have data analytics, which is nothing but after processing you need to do some insights or gain insights of the process data, like machine learning, predictive modeling, based on the metrics you gathered from the sensors. Let's say if a sensor transmits the threshold value between 7 to 10 all the time, and sometimes it goes above 10, and you need to know, first you need to take action if it goes above the threshold. Second, you need to know why it went above 10. So for taking action, you need to know what's the value which is transmitted by the sensor, and then you also need to know why it went above the threshold, right? So for that, sensors would always transmit all the data, from the device. So you will know what triggers, value goes up or above the threshold. These all comes into the data analytics side of it, or in the data processing layer. And then comes the application layer. So now you process the data, you find something, and then the action, which is either you interact with the application, do something to see, to rectify what has happened, or you feed that process data into another machine. Let's say you create a rule for it. Let's say the value goes above the threshold 11, and you also already created a rule. If it is 11, do this. If it is less than 7, do this. So you just feed that program into a machine, which automatically does something based on the rule you created. So everything will be autonomous here. For a simple device, it transmits the data, you process the data, and then you just feed the process data into another machine, which will just work based on the rule you created, and then it circle back to the machine, does something, and again it started generating data, and it's like a full cycle. It's autonomous. No human intervention might be needed in this case, which might be applicable for a small devices or small scale industries. But for a very large scale industries, everybody will prefer to have some kind of a human intervention, so that nothing goes on the other side. Yeah, this is basically what I summarized. Basically how IIoT works. Data acquisition, which collects the data transmission, from sensors to edge devices using various protocols, and then the processing layer, where the edge devices perform initial processing such as filter or anomaly detection, and then to the data storage analysis, which stores the data in the cloud, process it, and finds the insights, and then go to the actionable insights side, basically the decision making side of all these things. And also you can do predictive maintenance or process optimization and improve resource allocation. Yeah, I'll just highlight some of the key technologies and protocols in IIoT. Sorry, my font, or this font is not supported maybe in the browser version. So this is the communication protocols, which is MQTT, the message queuing telemetry transport. The second one is open platform communications unified architecture, and then advanced message queuing protocol, which is we usually use the message queuing protocol, and then the latest enhancements we started using advanced message queuing protocol. And network standards, we already touched on LoRaWAN and NB-IoT, which is used for wide area cellular connectivity. And then we have a wide variety of data exchange formats. The JSON format, which is a JavaScript object notation, where you see a key value pair. For example, if it's a date, it will have a date and a date value itself. It is similar to XML, but in a different format. And then we have protocol buffers. These are all different data exchange formats between the sensor to, from all the way to the data processing layer. These technologies and protocols form the backbone of IIoT systems, enabling seamless communication and interoperability between diverse industrial devices and platforms. The choice of specific protocols depends on factors such as application requirements, network infrastructure, and even system compatibility. Moving on to next. Again, this is just a key components highlighted again: sensors, actuators, networks, cloud computing, data processing, security. If you see at a very high level, the components or the architecture is very simple, just very similar to Internet of Things. But then, uh, since it is happening at a very large scale, uh, you know, uh, that's where the power of industrial, Internet of Things relies, where you can control massive systems using the data you collected from the sensors. The current state of industrial Internet of Things. For example, the global IIoT market is projected to reach by 260 plus billion by 2027, growing at a 16% from 2020 to 2027. The adoption rate is 70 percentage, which is very huge. And if you see the connected devices grows by like 25 billion connected devices, and it's growing even faster than ever before. Uh, we'll, I'll just touch on a case study, but I'll pass before we'll jump into the case study if you have any questions.
Hello, sir.
Yeah. Yes.
Sir, can you give some real-time applications of this industrial IoT?
Yeah. So this case study will give an example or like like what we are solving as part of Walmart. This is one of the case study that we are solving with the IIoT. So I hope that will help. Any other questions? Okay. Okay. So in retail, we face a lot of issues when we import an item from multiple countries. For example, banana. Banana is imported from countries like Mexico, Honduras, Central America, or from Asia, or from multiple countries. Right? But then, if there is a bacteria or if there is an infection, it's really tough to trace back which country's item is affected. The current system doesn't have a clear way of identifying this set of bananas came from this country. So we are facing that issues, and we are trying to solve that issue using IIoT. You see, it involves multiple geographies. The items travel from multiple countries to multiple ports, and then finally comes to the retail shop. It undergoes numerous transit and handling stages, which increases the risk of spoilage and contamination, and it has limited visibilities to the tracking, the conditions of the product, so many things, like when it gets transmitted from one geography to another geography, or during the transit also, uh, it's not clearly recorded, like what's the temperature that product is maintained, or when that becomes not usable. For example, if you transport one produce item from one country, by the time you receive it already might have not in a usable state. So you need to keep the temperature or maintain the temperature for item specific temperature, but then you need to have a different set of sensors to do it. So we started doing it to resolve this. So how we solved it? First, in terms of traceability, we started collecting environmental conditions, harvest dates, and even from which country this particular item is produced, using the sensors, or gathering data for that particular item from the origin itself, so that you have the sensor emitting data about that item at each level, where it produced, where it gets loaded into the truck, where it gets transported into a ship, and then how it unloaded, and how it came to a distribution center, and then how it get into our store. This is the whole the process that an item go through. But we started gathering all the information using the IIoT enabled traceability. We call that as IIoT enabled traceability. So because of this, we were now able to improve the food safety. For example, you can clearly know uh, what temperature this item is maintained, or if something goes off, we will be immediately alerted or notified by the changes through the data. Like this system is not working based on the data emitted by the sensors. And it also helps reduce waste, because you know since the sensors transmitting data from each segment, uh, it helps reduces spoilage, because at some point, uh, during the transport itself, if we say, or before the transport, we check the sensor data, it's looking good, when then initiate the transport, or if we identify this particular set of items might not be in a usable state when it reaches, so we will uh, you know basically substitute those set of items with the fresh items, and then basically ship it, so that it's not wasted. And it also improved efficiency. For example, uh, because of this sensors transmitting data in all the places, it helps uh, provide accurate information, faster delivery times to the customer, because the customer knows where the product is when he orders. And it also reduced costs, by reducing the overall cycle of the product. Yeah, I'll just take a pause and see if this helps you in identifying or relating this to a use case to an IIoT. Okay. Okay. These are all some of the other sectors where they started using IIoT. For example, supply chain. This also done by various big companies like DHL, Walmart, UPS. For asset tracking, inventory management, and logistics optimization, where the sensor, transmits the data to gain visibility to asset location, condition. You know, it helps in the inventory management. It also helps leading to faster delivery and reducing fuel consumption. This is similar to Walmart's, because this is in the supply chain side. And maybe this will be a different sector in energy utilities. uh, Maybe you might have all started using the smart grids, where it gives you, or it gives the government the capability to detect faults and optimize energy distributions in real time. Because of the smart grid installation, they will know which area is getting affected, or where we need to improve the, if energy distribution, using the smart grid, smart meters, and even optimized operations. So these are all connected together. Example, Shell uses IIoT to optimize its oil and gas operations, and Schneider Electric, which is another big company, uses IIoT for power distribution and automation. And this is in the pharma, healthcare and pharma. So again, you might see the supply chain or quality assurance or equipment monitoring in all the sectors, because it's all related to machines. uh, with the help of machines, how do you improvise your supply chain, and with the help of machines, how do you improve the quality. So the system names, or the underlying use case might be similar in all the sectors, but the problem that they are solving is unique to each sector. For example, in this case, healthcare, for all the equipments, heavy machineries or equipments they're using, they gather all the insights, and see if it's functioning properly. For example, if you go to a hospital where they have a big scanning machine or big X-ray machine or MRI machine, which has all the sensors in it, so then they will analyze whether the machine is functioning properly, or it does it needs regular maintenance, or it needs to be improved, something like that. And it also helps to improve the quality of the machines with the data it provides. For example, here, Philips is leveraging IIoT to improve patient care and operational efficiency. This enables real-time monitoring, remote patient care, and predictive maintenance. And I think in Europe and in other Asian, East Asian countries, they started implementing IIoT for precision farming. So based on the data, basically on soil condition, weather, crop, they are trying to improve the produce, or maximizing the crop yields, or even automating the irrigation methodologies, by using the machinery itself. So this will help them reducing manpower, and at the same time it increases crop yields, and it also helps them reduce water usage, or I would say optimized water usage for the agriculture purpose. So we talked about all the positives, and now we can talk about some of the challenges and the solutions that can tackle the challenges. When we start handling IIoT data, it tries to connect various systems, and sometimes when you try to connect two different systems, uh, an interoperability will comes into place, where this system cannot works with this system. Sometimes it might not be scalable. You can execute, or you can make that machine works for one, or maybe 10 or 50 or 100, but it might not be scalable for like thousands, or 2000s or 3000s at a very large scale. So again, it comes to the integration issues, like silo data. Not sometimes when a sensor started sending a static data, you may not know which is right data or which is a static data. For example, it started sending 7, and every time it's just sending 7, you might not even notice whether that 7 is accurate, or it's just sending the same 7 all the time. Sometimes the issue will happen without the sensor notifying us whether it's functioning not properly or not. And the adoption rate, the adoption rate is very slow because of the massive scale of the IIoT industry. You need really a good amount of hardware and machine power to gather the data and process the data. So the solution approach is like a pilot projects, where you just create a solution for one particular pilot, and then slowly expanding it to multiple projects, or slowly expanding the use case into multiple settings. Same as a modular approach. You just create a solution for one module and then expand to another module. And then you have a lot of IIoT vendors where you can leverage partnership with, so that they can help you implement the industrial Internet of Things at a very large scale. The main challenge is the security and privacy considerations. Threats, implementation security, monitoring and respond, and then continuous improvement. For example, threats. There's a potential cybersecurity risks to your IIoT deployment, because it's a very massive implementation where the sensors are connected through networks. So we need to be very careful in implementing at a very large scale because of the cybersecurity issues. and we have to have a very proper protection, security protection enabled in all the network layers. And security measures, you need to enable encryption, authentication, and access controls over the IoT network to safeguard the threats. And then we have continuous improvement, where you can always improvise your security protocols or security measures, and conduct vulnerability assessments, so that your network and your data is always in a safe spot. uh, I'll take a pause here and see if we have any questions. Almost towards the end of the presentation.
Participants, please ask your questions. Please unmute and speak.
Good evening, sir. Good evening, sir.
Yeah, Beanie.
What are the protocols we have to use to solve this infrastructure, especially for agriculture?
Sorry, I'm a little bit trouble hearing you. Little bit not audible.
Sir, please repeat.
Yeah, please repeat. I was hearing some background noises, so I couldn't fully get.
Hello.
Yeah.
Hello, sir. Myself Pratik Jaiswal.
Mhm.
Actually, sir, I want to work in IoT for my PhD purpose. Please guide
Mhm.
me regarding the IoT domain. What can I do for betterment of society?
Yeah, you can always. I think I shared my email. If not, I'll just share it at the end of the presentation. My email and the LinkedIn. Feel free to connect me. Through LinkedIn or email. We'll discuss it.
Sir, please can you share it again?
Yeah, I will share it at the end of the presentation. I have attached my email ID and my link, LinkedIn profile. Yeah, you can also type in your question. Sorry, type in your questions in the chat. If anyone. Okay. Yeah, future trends and emerging technologies in IoT, AI and ML integration with the recent advancements. You might have already heard about ChatGPT, OpenAI. So with the recent advancements, now the machine can started reasoning well, I would say, with the sensor data. Very soon, the machines can autonomously make decisions and improve the operations and improve the IoT space. Uh, and, with edge computing and even with the digital twins, uh, digital twins is nothing but your virtual simulations of physical assets and process to optimize performance and predict outcomes. This term is becoming popular nowadays, and many companies started to adopt digital twins. But these are all the very latest and emerging technologies in the IoT space. You might see uh, there will be large advancements, going forward in these areas. Yeah. summary and key takeaways, I would say we have a transformative technology, and we have data-driven decision making. We have a lot of challenges, which provides a lot of opportunities in the IoT space. And we also need to keep in mind that our strategy should always be future ready. You know, if you look at the overall process of IoT, you need sensors for gathering data, and you need network for transmitting data, and then you need analytics and processing for storage and process, and then you have an application layer or a human intervention layer where the process data will help you to make an action. And combining all these, security plays a very critical component here, you know. So to summarize, it's not just a technological trend, but a fundamental shift in how industries operate. So organizations can unlock, you know, new levels of efficiency, innovation, and competitiveness. The future of industry is connected, intelligent, and data driven, and obviously the IoT is the key to unlocking that future. You might have heard a lot of other things like AI, ML, you know, AGI, uh, prediction, you know, predictive modeling, but everything is going to help industrial internet of things or advanced industrial internet of things, because of all the other new technologies that's emerging, that is going to help you make better decisions or getting better insights on the data. So the recent emergence of technologies even help industrial internet of things move forward at a very faster pace. Yeah, I hope this helped everyone, and please ask questions if you have any.
Any industrial sensors available, IoT sensors available for voltage in the market?
Definitely there will be available, but it depends on, you know, like what specific use case that we are trying to solve. We can always connect, you know, through LinkedIn and or through email to discuss, because I
Okay,
cannot
sir. Thank
say
you.
something, you know, just for one use case or just for one, you know, like a very high level an example, right? So everything should be very you know, challenge focused or problem focused, so that we solve that particular problem, you know, in a more efficient way.
A few questions from participants in chat box.
Yeah, just saw that. Challenges involved with implementing IIoT. Yeah, security is one of the very big challenge where you need to have a, you know, a proper security authentications, you know, or enabled at each network layer or wherever it's get connected over the network, you know, because cyber security is one of the real threat identified by everyone, right? So security is really a one big challenge, and also interoperability, where uh, where you try to connect multiple systems in multiple places, where sometimes one system cannot interact with another system, but this interoperability can be solved by upgrading the systems, or, you know, or that might be a workaround. It depends on the use case again. Application, yeah, drone based IoT, yeah, again, it 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 is it is a good IoT use case, drone based, but what problem that we are trying to solve? If you are trying to solve you know, autonomous delivery of a product from one location to another location, yeah, it is possible. I think now they already started implementing it, even in you know, in some of the states in India, like especially in the medical industry, they are transporting drone from one environment to another environment. But I'm not sure whether it's fully automated. Sometimes you know, human is still controlling the device from one end to another end, but soon it will be autonomous, based on the data and based on the recent advancements. Sensors for identifying threats and unauthorized users. It depends on the, again, what kind of threats, because cyber security threats, you can have a various protocols to block the cyber security threats, but then there are hacking, so you need to build the machines unhackable, or unauthorized users, you need to just improvise your authorization mechanism or authentication mechanism so that no unauthorized user is getting access to the data. So data management techniques in IoT as data in massive number. Yeah, so data management is also one key area in the IoT, because sensor is emitting data at every second, every minute, right? So you need to design, basically you are going to collect the data and store it in a cloud environment for processing, right? So you need to design a table or design the file structure uh, in such a way that it is used efficiently for the processing and for the reporting, or for the next steps. There might be several layers in the storage. For example, uh, the raw data that comes from the sensors, you can store directly as your raw data. That is a stage one. And then the next layer is kind of, you just take whatever is needed from the raw data and store it for processing purpose, because you might not need all the data, because if you see a sensor, it will emit almost same data. I would say the values might change, but the other you know I would say the same, the key components. For example, the sensor has some information, the name information or the device information. It might be repetitive all the time, but only the value, what is it emitting, its temperature or its pressure, only the temperature or the pressure, what is critical for your use case, the time and temperature, time and pressure, everything is time bound. So you need to have a well defined structure while storing the data, and also while designing the table you need to have a lot of optimization techniques while designing the tables, or even storing the data inside the tables, like a partitioning, clustering, for efficiently processing all the data. So when it comes to the data management, it really is a designing area where you design it properly, store it for processing. See some protocol we have to use for agriculture. Mm, uh, it depends on what kind of irrigation, or what kind of agricultural methodologies that you're trying to solve. For example, for planting, we have various machineries. For water usage, we have various sensors. Based on the crop, based on the soil, you can control the watering time, frequency, using the sensors and the programs. And sometimes even you can attach or add the weather or the climate information to the sensors or to your application. Basically, you can control your watering, um, time or frequency based on the weather. If it's more, if it's going to rain, you can stop your, watering process, or if it's not going to rain, you can still continue it. There are so many techniques or so many optimization process that you can do. So IIoT basically enables you do this based on the data, at each level, soil level, climate, uh, the crop, so many things. Okay, so using IoT technology, yeah, disease monitoring, yeah. So you can have a so disease basically how you identify disease. There might be some subject matter expert, for example, for certain kind of crop, this is the way you identify a disease, right? So with that, as a subject matter expert, you can define the role for that disease. Or sometimes you can identify the disease for that crop using a sensor. I'm not sure, it depends on the crop or depends on the use case, but using a video camera or using a different methodology based on the crop, you can still identify whether the crop is having a disease or is it changing something, it's in its nature. It is still possible, but it's a very wide area. You need to do some research whether it's possible first, to do it using sensors, or to do it using IoT, the disease monitoring. Give some examples of industries. Any industries that uses machines can be benefited through IIoT. I would say, nowadays, let's say your car manufacturing industry or your any manufacturing industries can benefit from IoT. Any even connected cars can benefit from IoT. You can if you just gather insights from your car, it's going to be just for you. For example, Tesla is an electric car, and it has data about the cars for all the cars, right? So the company can see its performance, what needs to be improvised, right? It has so many data within itself, so there are so much, almost every industry can really benefit from IIoT, I would say. Yeah. So in the Walmart, I'm not the direct and I don't get directly involved in the implementation side of it, like the hardware side of it. I'm at the data storage and the processing side of it, and even gathering insight side of it. But the other teams, it's a very big team, where some teams, uh, implements the traceability protocols, and some teams will implement the sensors in different segments. We gather all the data and just process it and uh, sends the feedback or the insights to the appropriate team so that they will take actions on it accordingly. Any other questions? Plant related things. Uh, plant related things. Yeah, accuracy is still improvising stuff, I would say, because the accuracy gets improved when you train the model with more number of samples or more number of data, right? So accuracy goes to the machine learning part of the predictive modeling or AI side of it, but IIoT is more on the information gathering, processing, and giving insights. Sometimes the recognizing something, recognizing sandalwood, or which type of plant it is, those are all the final machine learning stuff. Or I would say there are two aspects I said about actions, right? One is human action, one is the machine action. These recognizing or identification are all machine actions. where you feed all the process data into the machine to predict something or to identify something, whether it's an yes or no or binary identification or like clustering based identifications. It's based on the data that you provide, or it's based on the data that it's trained. So it's all machine feedback, you know. Yeah, any other questions? I hope I answered most of the questions.
Any questions from participants side? Yeah, yes.
Any other forum or company is maintaining to do some collaborative research or anything?
Sir, the
Collaborative.
session was very interesting. Thank you, sir. Thank you very much.
Yeah, thank you for feedback.
Thank you.
Any other industries for collaborative? I would need to do some research. Definitely there will be some vendors, you know, available for collaborative work for IoT especially, but it depends on, you know, which industry or which segment, or, you know, what type of a problem that we are trying to solve. It's all about the problem, you know, that we are trying to solve. Again, when we start think about IoT, start with one simple module or one simple, you know, pilot project, so that when we implement or when we start to implement, then you slowly expand that module into, you know, multiple modules or a big project, because that will only help you implement. Otherwise, it will be difficult to implement a very large scale project at a very initial stage.
Yes.
That's all from my side. Thank you
Yeah.
everyone for your feedback.
Yes. Nice, nice session. Thanks, Arun. But in the starting session, we are not introducing you. So just a small intro about you as well as a thanks.
Yeah,
Dr.
sure.
S.V. Anandi, ma'am,
I'm just
hold on a
sharing
second, ma'am.
the LinkedIn profile name and the email ID in the
Via
last
chat
slide.
box,
Just,
please. Yeah. Dr. S.V. Anandi, ma'am.
yeah, thank you.
Sir?
Please, ma'am.
Okay. Thank you
Please
so
introduce
much,
Arun
sir.
as well as thanks.
Okay.
Yes, audible, ma'am. Go ahead.
Thank you so much, sir. I hope this session will provide you all a valuable and memorable time of experience in knowledge gathering. Once again, I would like to thank the resource person for the session day one of the 6 days online Atal FDP on artificial intelligence edge soft computing. Actually, Mr. Arun Sundar Selvam is a senior software engineer, Walmart Global Tech, United States. He completed his BE in 2011 from Sri Sairam Engineering College and did his postgraduate program in business analytics and business intelligence in Great Lakes Institute of Management in the year 2016. In mid of his higher studies, he had been working as a senior Hadoop engineer in Tata Consultancy Services from November 2011 to September 2016. And then he continued as a consultant in Clarity Insights from September 2016 to March 2019. Later on, he worked as a engagement manager in MU Sigma from May 2019 to April 2020. He is in Walmart Global Tech from April 2020, where he is a senior software engineer till now. He is a MAP or certified Hadoop developer. Once again, I thank you, sir, and participants. Now I hand over the session to Mr. Saravanakumar, sir. Thank you, sir.
Thanks, Arun, for a nice session. Yeah, even busy schedule, you accept our invitation and take such a nice session. So very sincere thanks to Arun. Thank you. Thanks a lot.
Thank you, everyone. Thank you.
Dear participants, feedback link is posted in the chat box. Kindly fill the feedback.